Is there a reproducibility crisis in science? Can you trust the scientific literature you find from esteemed professors, or are all published papers just to be doubted? Is science doomed? The answer is just as clear as the experiments that this issue surrounds. That is, it's not very clear. But I think that, while reproducibility and scientific integrity are massively important to science and publishing scientific claims, the whole of science is not in a so-called crisis, and I do believe that, with careful work and proper education, we can continue producing valid and trustworthy scientific results. The issue of this reproducibility crisis that has sprung up in recent years began in the field of psychology, when participants from the nonprofit organization Center for Open Science attempted to replicate 100 experimental and correlational psychology studies. Only 39 of them were successfully replicated. Only 39 of these 100 studies had produced the same findings after multiple trials. The other 61? Well, who knows if the findings were scientific truth, or if the results were chance, or worse, fully incorrect. Yet, despite the inability for psychologists to reproduce these studies, all 100 had been published in prominent psychology journals. They were part of the scientific literature that professionals look at today. Similar issues have sprung up in other fields of science, from chemistry to the medical sciences. Professors are publishing papers on experiments that cannot be replicated, reporting conclusions that can't really be backed up. So why is this? One major contributor to the problem is the publishing system for these papers. For scientific professionals, there's often this idea of publish or perish, which means that scientists must publish papers frequently in order to keep their jobs and their esteem. Because of this pressure to put out papers, some individuals are more likely to publish incorrect or weakly supported results. It's harder to strive for perfection when you've got deadlines to meet. Additionally, the review process for these papers isn't very strong, and the reviewers don't receive compensation, so they're more likely to let erroneous data slide. Publication bias also fuels the reproducibility problem. This is the concept that publishers are more likely to publish papers with brand new, never seen before ideas and unexpected results, and are less likely to publish papers that negate ideas or prove null hypotheses, or that show data that is expected. Because of this, some scientists alter their data to make it new and flashy. They also may not change the data itself, but rather change the question that this data is answering, thus forming conclusions that shouldn't really have been reached. This connects with the next issue. Many scientists don't fully understand the statistics they are using to back up their claims. Some use the p-value to validate claims that aren't really true, and others change the data sets so that it becomes statistically significant, also called p-hacking. Still others throw out data that shouldn't be thrown out in order to change the centers of distribution. Because of these problems, there are many scientific papers out there that describe experiments that can't be replicated due to altered data and weakly supported conclusions. Thus, the reproducibility crisis. When we can't take an experiment and do it again to prove its results, can we really trust that experiment? But like I said before, I think that crisis is too strong a word to use to describe this phenomenon. In fact, I think that many of the papers talking about a replication crisis are actually falling for the same trick they're trying to stop: novel and flashy ideas. Because isn't it true that a paper stating that a drastic number of scientific papers are actually incorrect is more likely to be published than a paper that states that everything is going according to plan? I do believe that not all hope is lost, and that the majority of science that is out there is good science that we can continue to use to strengthen our understanding of all sorts of fantastic ideas. But in order to keep there from being a true crisis in the future, we do need to make some changes right now. For one, I think that there should be better education about the statistics that goes into making conclusions for data. Many scientists don't understand the statistics that they are working with. They just find a p-value lower than 0.05 and call it a day. If our understanding of these concepts is strengthened, we can find stronger and better supported results that are more likely to be replicated. Additionally, the publication process and expectations need some reform. We can't maintain this publish or perish ideal. We need to allow scientists time to work with their data and not feel the need to manipulate it or publish incorrect work. Publishing companies should also be more eager to accept negative results so that we can continue to deepen our understanding of previously studied concepts rather than just scrambling to produce something that is totally new. Overall, I believe that reproducibility and scientific integrity are very important to scientific work, and if we strengthen the statistics and fix the publication process, we can nip this whole crisis thing in the bud.